This lesson on Automotive Mythbusters from David's Farm is on souping up engines or engine performance. So first, for my younger viewers, as they kind of ask me these same questions all the time, what is compression ratio and what does the size of the engine mean? Well, engines are measured in cc's or cubic inches, and compression ratio is a ratio. It's the difference between this space and this space when the piston is at the bottom. For example, if this space in the cylinder head that's above the piston, whether it's an overhead valve engine or a flathead engine like this, if this total space up here, including the space that thickness of the head gasket makes, would be, say, for example, 10 cc's, 10 cubic centimeters, and this space with the piston all the way at the bottom would be 100 cc's, well then your compression ratio is 10 to 1. That's called a static compression ratio. If this engine was supercharged or turbocharged, then more air is coming out of the valves, intake valve into the combustion area and it's under pressure. So then you have a second compression ratio and the engine is under the boost condition, and that's called effective compression ratio. And that could be 2 or 3 points higher, 12 or 13 to 1 when there's lots of air being forced in there when the motor's running at a higher RPM. The size of the engine is just how many cylinders it has and what their displacement is. So displacement is, say for example, when that piston's all the way at the bottom to the top of the head, that's 100 cc's. Well, if that was an 8-cylinder or 6-cylinder engine in a car, well then you multiply 100 cc's times 8 or times 6. So that's how you measure engine sizes. It has nothing to do with the size of the block or anything like that. 95% of all modifications you make to an engine to give it more horsepower have nothing to do with the engine block. There's only 2 modifications you can do to the engine block to give it more horsepower. First is bore it out, the boring machine. Then you'll have to put a bigger piston in there, but then that gives you a bigger hole, so your engine becomes a larger size. Maybe it become 110 cc's now. And that would also change your compression. If this became 110 cc's, and that still stayed the same at 10 cc's, well then you'd have 11 to 1 compression ratio, so every time you increase compression, you get free horsepower, and of course you've got bigger space in air exploding, so that gives you free horsepower. The only second other modification you can do to a bottom, this is called the bottom end of an engine, is to make a stroker out of it. That means to put a different crankshaft in, or a modified crankshaft, where the pin that the connecting rod goes to is a greater distance from center. That means it has a longer stroke. But of course you just can't throw the wrong crankshaft in an engine, because then the piston would come right up so high that it would be sticking out of the cylinder like that and hitting the head, and of course then the engine couldn't rotate. So what they do to alleviate that problem is you put a shorter connecting rod in. There you go. They do this all the time to 350 Chevy engines and make 383 strokers out of them. So that's all you can do to the bottom end of your motor to give your motor more horsepower. But if you give your motor more horsepower by all the other peripheral means, everything else you can do to your motor, you may want to strengthen your bottom end. Well, for example, almost every car comes with just a cast iron crankshaft like this one. General Motors cars pre-1967 all came with forged steel crankshafts, which are much better. Volkswagens come with forged steel crankshafts, BMWs do, and lots of other good cars. But if you put lots of horsepower in your engine, a cast crankshaft can break very easily and it flexes more. A forged steel crankshaft always springs back when it's flexing. The metal is harder and stronger and more resilient, and that's much better. Next would be stronger rod bearings. This particular rod doesn't have replaceable bearings, but you can, on all car engines, you can replace the bearings and put better rod bearings in. Next thing would be to have this higher volume, higher pressure oil pump, so there's more oil in those bearings between it and the surface of the crankshaft, so you don't spin a bearing. When you spin a bearing, that means that little insert in here, which is only held in by a notch, twists around, and the hole that's drilled in it, that oil squirts out of, lines up, it's supposed to line up with this hole. This squirts oil on your rings and on your cylinder when the piston's going up and down. Well, if it doesn't line up anymore because that little insert is shifted, well then now your engine is not lubricating the cylinder walls, and that can cause scoring like you see here. Seize up your engine, damage your engine, and pretty much always when one of those things slips and moves, it means it seized onto the crankshaft for a second because you didn't have enough oil volume or pressure, and that causes damage here and here, which quickly wears out your engine and gives them what's called a knocking sound. If you want to make your engine rev quicker every time you accelerate or step on the gas, well, you put a lighter flywheel in. Instead of the big heavy cast iron flywheels, they have special flywheels that you can put in for racing vehicles. Also, if you've modified your engine to run at much higher RPMs, having a lighter flywheel is better because then it's less likely to explode and detonate and come to the floor and kill you. Now, all the other modifications made to engines that are mechanical have to do with flow dynamics to give you more horsepower. By flow dynamics, I mean the airflow into the engine and how fast you can get it out of the engine, which means the exhaust, and fuel flow. So first you would look at the air filter. Well, cars come standard with paper air filters, which aren't that great. You could get a K&N slightly oil-soaked air filter, which has much greater flow. The next thing is, cars don't come with those so-called cold air intake pipes. Well, as you can see, this has a few ribs in it, and it's not perfectly smooth inside, and it's not as long as it could be. Well, so if you wanted to put one of those little pipes on and put one of those high flow air filters on, well, then under high RPMs you can gain a couple horsepower. The next step in increasing horsepower in your fuel injected engine could be a bigger throttle body. The throttle body is the place where that throttle plate moves and flips over inside the air intake pipe. So you could have it would have a larger flapper on it and larger hole. Next part is the plenum. That's the part that collects the air before it sends it down to the runners. Larger plenum, larger runners, and longer runners. That increases torque. Your fuel injected car could be throttle body injection, so that means you might just have one or two injectors at one point, and then everything feeding off from there. The better system is like this, where it has one injector for each cylinder, and this one has the better computer programming called SFI, sequential fire injection. Now there's the exhaust. This is what you would call a semi-header. If you took that heat shield off, you would see that the manifold comes out and has runner lengths to its exhaust tubes. Then they all go to one. A full header would have pipes that would come off 3 or 4 feet long. They would go and curl underneath the engine and then all join to one, or have 4 single outputs for racing purposes only. Now every time you make modifications to the flow dynamics of any engine, your fuel consumption and your amount of fuel mixture has to be changed, which means changing fuel pressure, changing injector sizes, or changing the size of jets. When an engine has increased exhaust flow or increased intake flow, it always needs more fuel to mix with the air coming in, or the engine will become too lean, which is bad and can cause burning valves or pre-detonation. So you would put a bigger jet hole in your jet, or a completely different jet if this was a carbureted vehicle. If it was a fuel injected vehicle, you would put bigger injectors in, or higher fuel pressure, and or you would put a modified computer in, or one that's programmable by a laptop. Give it a longer fuel pulse. That'll give it more fuel. Now I've talked about the things you do outside of your engine block that gives you more horsepower, except for turbo and supercharging. Now I'll mention the stuff that's most important, which is head design. Of course, the more valves you can put in a head, the better. That means it can breathe better. You can get more air in and more exhaust out. This one's a 16 valve. That means 4 valves per cylinder. This one's a semi-hemi head, which means it does have a semi-hemispherical head, and because it has that, the spark plugs have to be in the middle of the rocker cover because they're in between all 4 of those valves. Hemi heads are typically the best because of their half hemispherical shape, they propagate the shock wave of the explosion down really well and evenly against the piston to help push the piston down, and that also helps it to become a bit more efficient engine for fuel consumption. In the cylinder heads of all vehicles is ports, exhaust ports and intake ports. Well, if you increase the size of those, and then also increase the size of the ports from the plenum and the exhaust that bolt up to them, and match them, well then you've right away there increased dynamic airflow. That gives horsepower, if you have enough fuel mixed with it. Well, if you're going to go to all the trouble to do that, then it'd be a good idea to put a better camshaft in. That would have bigger lobes on it for higher lift so it can open the valves more to let that extra air in, and different durations on it for overlap and stuff like that, so the valves stay open longer when the engine's running at high RPMs to give it more horsepower, so it gives it more time to get the fuel and air mixture